So, hello everybody. In the previous video, we talked about the RMS values of current. So, IRMS was equal to I naught upon root 2, that is the peak value upon root 2, which is 0.707 I naught. Last video में मैंने गलती से 0.707 की जगह 0.63 नोट किया था, तो please don't mind. Then similarly, VRMS is equal to V naught upon root 2, again the peak value of voltage upon root 2, which is 0.707 V naught. And you know the relevance of IRMS, because IRMS and VRMS, to produce the same amount of heat in a DC circuit, I would have to give I naught and V naught value. But to produce the same amount of heat in an AC circuit, I would have to give just this much value, 0.707 I naught, for for the same amount of time. Okay, so this is also a important aspect of AC that we are getting, is that to get the same effect, we would have to use lesser value of DC when we are creating the, what I mean to say is, सेम अमाउंट ऑफ हीट प्रोड्यूस करने के लिए AC को कम कांस्टेंट करंट चाहिए in comparison to the DC circuits. So this is the beauty about it, and we would try to write this in some steps also, in some wording, so that it would be more understandable to you. Now let's apply alt AC on purely resistive circuit. Means I'm gonna give AC source to a purely resistive circuit. This is my AC source, and I'm giving it to a resistor R. So what's going to happen? I know that E is equal to E naught sine omega t, and let's add phi also so that it becomes more generalized. Now, and but E is equal to IR. Yes, so if that's the case, I would be I naught sine omega t plus phi into R. That is I naught R sine omega t plus phi. That is my E. So E naught is basically equal to I naught R. Yes, and this further gives me the same expression, E is equal to E naught sine omega t plus phi. So we can see one thing through this expression, कि चाहे I का expression हो या EMF का expression हो, alternating voltage का expression हो, जो मेरा phase है, that is omega t plus phi. Phi is the phase constant, omega t plus phi is my phase. So ये जो मेरा phase की value phase आ रहा है, phase variation आ रहा है time के साथ, वो दोनों केस में same आ रहा है, omega t plus phi, omega t plus phi. So this means if I would have to draw the graph showing the variation of I and V with time, I'll see that, let's say V naught is this much and this is I naught. Then I'll see that if I'll make V naught graph like that, this is my cycle of V naught, then I naught will also have the same time period, but the maximum value is varying, and that has to vary because these are two different quantities. One is the voltage, another is my current. This is minus I naught and this is minus V naught. So you'll see that the current is the direction, and this is how the cycle would get complete. So these two things, this is what we call in phase, voltage and current. Voltage and current are in phase. They are both going with the same speed. The value, the variation that we are seeing in the value of current and voltage, it is happening at the same rate. Nobody is lagging there. If voltage is increasing, current is also increasing, and that is also happening in the same time. This is, here we are showing the time. This is what we call in phase quantities. Okay, so voltage and current are in phase, and if you would have to draw phasor diagram, we'll come to that later on. Let's come to that later on. Okay, so the circuit resistances again are only. Now once this is done, let's come to another circuit which is called as purely inductive circuit. Now what is inductor? If you remember, what is inductor? Inductor is a coil made using insulated conducting wires having N turns. Yes, so it's a AC, so I have to make this. This is a purely AC circuit because here I am applying this AC source omega t plus phi plus this phase diagram which I have made. Here I have taken phi equal to 0. Okay, तभी ये ऐसे हो रहा है, वरना ये यहाँ ऊपर से शुरू होता. Now this is I naught sin omega t, and if I talk about the EMF, it would be E naught sin omega t. So let's not write I naught here because I'm just gonna give it some EMF. How it is going to generate the current that it's going to experience, and the current that is going to pass through it is decided by this device, which we call as inductor, and it has inductance L. If you see it generally, it's just a wire made up of, it's a conducting wire. So conducting wires have very less resistance. Yes, conducting wires की resistance बहुत कम है, तो वो current को तो resist करते ही नहीं है. But the whole game starts occurring because it has been coiled like this. And when it is coiled like this, and I have an AC source placed here, the magnetic field passing through this, the magnetic field generated through this coil would change. Why? Because when the current flowing through this conducting wire, this inductor is changing, the flux associated with that current will also change. ये आपने पहले चैप्टर EMI में पढ़ा होगा कि आपको पता है कि phi is equal to B dot A, which is further equal to Li. Yes, phi flux generated जो है किसी भी पर्टिकुलर कॉइल का, वो उस कॉइल की इंडक्टेंस और उससे पास होने वाले करंट पे डिपेंड करता है. Now if you change the current passing through it, like if I make it like L di by dt, the flux would change, and when the flux would change, again you will see that area is still same, the magnetic field will change. I'm taking B and A along same direction, B and A along same, and ये होगा किसके लिए? लॉन्ग सोलेनॉइड या लॉन्ग इंडक्टिंग कॉइल के लिए. So you can see that if the flux is changing, flux would change when the current would change, and the AC is implied by the change in current only. So it has to show some time span for which the variation would be happening across it. मतलब जितने टाइम में मेरा EMF चेंज होता है, क्या एग्जैक्टली उसी टाइम में इसके अक्रॉस भी करंट का वेरिएशन आता है, और अगर आता है तो कैसे आता है. Okay, so let's get the expression. So you can see that I'll apply the EMF E like this. I'm just applying Kirchhoff law here, and the voltage drop across it will be L di by dt. If you remember the last chapter, Lenz's law, E is equal to minus d phi by dt. Then you will put it here, then it will turn out to be plus. Yes, so this is how it is. So E minus L di by dt, the EMF generated across the inductor. This is what I have given to the circuit, and it is coming out to be 0 because these are the only two components in the circuit. So I'll put E naught sin omega t here equal to L di by dt. Now E naught, I can bring L here, sin omega t can be here, and then dt can be brought here, and this is my di. Yes, So let's do the integration. I have to put here phi also. This is your flux, okay? Don't take it same as this. This is your phase constant. These are two different things. Yeah. So let's do the integration. Very roast. So my expression was E naught sine omega t plus phi, and there was this L here and this dt here. Let's do the integration. Time limit will be 0 to t time period only, and here also 0 to t. So E naught upon L would come out because these are the two constants. In integral, I would have 0 to t sine omega t plus phi dt. Just a second. Yes, dt is here, and here it's di. Yeah. This is 0 to t di. So this is my I, which is changing expression for I, and this would be E naught L sine omega t. Integration of sine would be cos omega t plus phi upon omega. Limits 0 to t, and so cos derivative is minus sine. Sine should be minus cos. Yeah, it would be minus cos. So let's put the values. It would be E naught L. This omega can come out. Let's put the values. Cos omega t plus phi minus plus cos omega into 0 plus phi. Yes, that is my I. E naught L omega, this would be minus cos omega t is 2 pi upon t into t plus phi plus cos omega into 0 is cos phi equal to I, and this would be E naught L omega. Now cos 2 pi is 1. Yes, this is 2 pi plus phi, so I can write it as cos 2 pi plus phi is cos minus cos phi only, plus cos phi equal to I. So I is coming out to be E naught omega L, that is 0 into 0. That is for average, for complete cycle, current flow across inductor is also 0. इंडक्टर के अक्रॉस करंट फ्लो 0 आ रहा है. Yes. So if somebody would ask me, write an expression for I, then what would it be? It would be E naught upon L